You're listening to DTFHN for July 3rd, 2026. I'm your fully audible host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where mass disagreement is the only form of consensus. Today reeks of trust issues and locked gates. Let's kick them open. What does it actually take to make something that works? Not something that demos well, not something that closes a funding round. Something that a baker pulls bread from and says, "Yeah, that's right. This essay by Welly uses an extended metaphor." A startup building ovens. And it's one of those pieces where the metaphor is so thin you can see your own company right through it. A founder who knows markets but has never baked anything. An engineer who's spent a decade on Italian forums arguing about convection and refractory stone. 5 prototype customers whose bread comes out burnt 2/3 of the time. And a pitch deck that treats that 33% success rate as validation. Let's pull this thread. The founder raises €5 million on the strength of 5 customers. Nobody asked if they'd buy again. The engineer hires his forum friends. Brilliant oven nerds, deeply opinionated, zero experience shipping to real kitchens. The sales team has never touched an oven, but they're hungry. Everyone is optimizing for their own metric. The founder optimizes for revenue. The engineers optimize for the oven they wish existed. The salespeople optimize for closing deals on features the oven doesn't have yet. And the actual product, the thing a baker has to trust with their livelihood, falls through the gap between all three. Strip away the metaphor and the first principles are stark, building something that reliably calculates baking time for every dough, every humidity, every altitude, every flour, is a genuinely hard engineering problem. The kind of problem where 10% of the market looks trivially small in a spreadsheet but represents millions of edge cases in reality. The founder's mistake isn't ambition. It's confusing market sizing with engineering difficulty. The engineer's mistake isn't perfectionism. It's confusing opinion with validation. And the sales team's mistake isn't enthusiasm. It's promising outcomes the product can't deliver. One reader commented that this made them hyperventilate. Another said it reads like Dilbert, if Dilbert were a cautionary tale instead of a comic strip. The most telling comment came from someone who said, and I'm paraphrasing, "Oh, we're nothing like this. We're building a revolutionary dishwasher, and our prototypes are amazing." Which is, of course, the entire point of the essay arriving on cue. The tools to build great things exist. The knowledge is available. What keeps failing isn't capability. It's the feedback loop. When the people using your product can't reach the people building it. When sales promises outrun engineering reality. When form credentials substitute for field testing. You get a half-baked product. Literally, the oven works 1/3 of the time, and everyone calls it progress. Moving on. Let me make the case for the data brokers. Honestly, it's not a terrible argument on the surface. Location data powers fraud detection, urban planning, emergency response, traffic optimization. A world where no one can aggregate movement patterns is a world where city governments can't figure out where to put the bus stops. The data is already being collected. Your phone pings cell towers whether Virginia passes a law or not. So why not let a market exist to put that information to productive use? Restricting it just pushes the trade underground or offshore. Classic prohibition logic. Now watch the argument eat itself. There's a concept in ecology called an invasive monoculture. A single species arrives in a new habitat, faces no natural predators, and consumes everything. It doesn't matter that the species is individually unremarkable. A vine, a beetle, a particular strain of grass. What makes it destructive is the absence of constraint. It grows until the ecosystem collapses under the weight of one organisms, unchecked appetite. The geolocation data market is an invasive monoculture. The product isn't location intelligence. The product is the complete absence of friction between your physical movements and anyone with a purchase order. And the reason it metastasizes isn't because the data is uniquely valuable. One commenter noted that after 2 decades of following this market, they still can't figure out what this data actually costs. It's because nothing stopped it. No predator, no constraint, no immune response. Virginia's law is an immune response, a modest one, frankly. It only covers sales for monetary consideration, which is narrower than Maryland or Oregon's definition that includes other valuable consideration. And one commenter correctly points out the bill targets precise geolocation within 1,750 feet. Not all location data. You can still be tracked at neighborhood resolution. This isn't a wall, it's a speed bump. But speed bumps matter when you're dealing with a monoculture. Maryland moved first. Oregon followed. Virginia makes 3. California, Massachusetts, Vermont, and Washington have proposals in the pipeline. The FTC already banned a data broker from selling location data in 2024. The California AGA launched an investigation into the entire location data industry. This is how regulatory ecosystems develop natural resistance. One state passes a law. The sky doesn't fall. Another state passes a similar law. The data brokers adjust. The ecosystem rebalances. The vine stops spreading. Not because someone burned the forest down, but because the forest learned to fight back. The interesting question is whether monetary consideration is a loophole wide enough to drive a data sharing agreement through. The answer is almost certainly yes, but the direction is set. The monoculture's habitat is shrinking. Remember earlier, local first everything? That principle extends beyond code. Let's talk about the right to local intelligence. One of the top comments on Hacker News cuts right to it. Laws restricting local AI aren't going to happen, they say, because every major OEM is already betting on local inference. Apple, Qualcomm, AMD, Intel. They're all shipping silicon with neural processing units baked into the die. The hardware trajectory is set. You can't legislate against an instruction set. But that's exactly why bottertelligence.org matters right now. Not because the threat is imminent, but because the window for preemptive protection is open. Another commenter nails the strategic logic. Push proactively, not reactively. Repealing a bad law takes the same votes as passing one. Better to establish the principle before someone decides local inference is a national security problem, or a copyright liability, or whatever the lopping flavor of the month turns out to be. Let's pull this thread on the technical side, because the engineering reality here is beautiful. Running a 7 billion parameter model on a laptop with 16 gigs of RAM. Quantized to 4 bits, running through llama.cpp or ollama. That was science fiction 3 years ago. Today, it's a weekend project. The inference stack is fully open. GGUF format, community quantized weights, Metal and CUDA backends. Speculative decoding pushing tokens per second into genuinely usable territory. Every layer of that stack was built by people who published their work so others could build on it. Bootstrapism at its most literal. The latter exists because nobody pulled it up. The cloud dependency angle deserves attention too. One commenter said, depending entirely on cloud-hosted intelligence feels more fragile and invasive every year. They're right, and the fragility isn't hypothetical. API rate limits change, terms of service change, pricing changes. The model you built your workflow around gets deprecated with 30 days notice. Local inference doesn't just protect privacy. It protects continuity. Your model doesn't get a policy update at 2 a.m. that breaks your application. The manifesto itself takes a smart position on enforcement. Fraud, CSAM, harassment. Keep all of it illegal. Enforce it seriously. The right to run local models doesn't mean the right to cause harm. It means the right to compute, to think privately, to build without asking permission from a vendor whose interests may diverge from yours at any moment. The tools exist. The silicon is shipping. The weights are published. This is about making sure nobody gets to close that door after it's already open. Apple's next-gen CarPlay rollout is finally here. And this one's worth paying attention to. I've spent enough time building software to know that when someone tells you they're keeping control of every pixel for your benefit, they're keeping control of every pixel for theirs. Rivian's chief software officer was asked directly about CarPlay support, and his answer was revealing. He said screen mirroring solutions take over every single pixel, and that's not how Rivian sees itself interacting with users. The problem is, that's just wrong. Standard CarPlay does not take over the screen. It runs in a window. The manufacturer's UI lives above and below it, right there, coexisting. A Volvo XC90 demonstrates this perfectly. CarPlay occupies its portion. Volvo controls the rest. This isn't a technical dispute. It's a factual one. But let me argue his side for a moment. Suppose Rivian's in-house software really is superior. Suppose their maps, their media player, their entire interface genuinely outperforms anything Apple's ecosystem offers. That would be a strong argument for building a walled garden, right? Except it wouldn't, because CarPlay is optional. If Rivian's interface is that good, drivers simply won't plug in their phones. The existence of a choice doesn't diminish a superior product. It validates it. The only scenario where offering CarPlay hurts Rivian is if their software isn't actually better. And they know it! This is a pattern that repeats across every industry where software meets hardware. The manufacturer wants the entire surface. They want the data, the engagement metrics, the app ecosystem lock-in. They frame it as user experience. It's a business model. Rivian builds genuinely impressive vehicles. Their engineering is real. But the decision to exclude CarPlay isn't an engineering decision. It's a control decision, and control decisions have consequences. There's an entire cohort of buyers, the author of this piece included, who simply will not purchase the vehicle without it. The comments reinforce something worth naming. CarPlay's deepest value isn't any single app. It's consistency. You learn one interface, and it works across every vehicle that supports it. That's what a platform gives you. That's what openness gives you. Your muscle memory, your podcast app, your preferred navigation. All of it travels with you from car to car. A proprietary system asks you to start over every time you switch manufacturer. Apple is even addressing the last legitimate technical objection. iOS 27 will share route data with the vehicle, so the car's driving systems know where you're going, even when you're navigating through CarPlay. The excuses are running out. Build great software, Rivian, then let people choose it freely. That's how you prove it's great. We talked about building in the open earlier. Pause. Here's someone who's been doing exactly that for years, and just shipped something beautiful. Marjan Haverbeck has mass-produced the world's best rich text editors the way some people collect hobbies. He built CodeMirror, then ProseMirror, then CodeMirror again, from scratch, because the first one wasn't good enough. Now there's Wordgard, and if you've ever tried to build a content editor inside a browser, you already know why this matters. Run this forward. The browser gives you content, editable, which is technically a rich text editing a P and I, in the same way that a shovel is technically a surgical instrument. 20 years of web development, and we still don't have a native, reliable way to handle structured text editing in the browser. One of the comments nails it. After 2 decades, you'd think this would be solved at the platform level. It isn't. And that gap is why one person in Berlin keeps having to solve it for the rest of us. Wordgard is MIT license, open source. The code lives on Havebake's own infrastructure, not GitHub. Pull requests aren't accepted, which sounds restrictive until you understand the model. This is one of the most meticulous programmers alive, maintaining a tool that thousands of companies depend on. And the quality control is the product. He's asking commercial users to fund the work voluntarily. No license trap, no dual licensing games, no open core bait and switch, just good software and a social contract. The technical angle is worth pulling apart. Wordgard isn't a drop-in WYSIWYG widget. It's a toolkit for building editors where you define exactly what content structures are valid. That constraint is the feature. Every newsroom, every CMS, every documentation platform that's tried to wrangle free-form HTML into something structured has hit the same wall. And ProseMirror was already the best answer most of them found. Wordgard appears to be the next iteration of that thinking. One commenter flags the React integration friction that plagued ProseMirror. The New York Times had to rewrite the renderer to make it work for their use case. Whether Wordgard addresses that remains to be seen, but the architectural ambition is clear. This is what open source looks like when it's working. One engineer building in the open, funding the work through the value it creates rather than the control it extracts. The tools exist because someone decided they should exist for everyone. That's bootstrapism. That's how the ecosystem actually advances. Now for something completely different, and honestly kind of fascinating. Alibaba is reportedly banning Claude Code over backdoor concerns. There's a detail buried in this story that's easy to miss. Alibaba, one of the largest technology companies on Earth, a company that runs its own cloud infrastructure, its own large language models, its own developer tooling stack, decided that Claude Code, a coding assistant, posed a backdoor risk to their internal systems, and they moved to ban it. Now, the surface-level read is geopolitics, Chinese company, American AI tool, national security concerns. Standard playbook. But pull this thread a little further and something more interesting emerges. A few days before this announcement, researchers flagged what Anthropic called undocumented functionality in Claude Code. Telemetry behavior that appeared to collect and transmit location data in ways that weren't clearly disclosed. One of the Hacker News commenters links directly to the disclosure. Whether you call that a backdoor or a bug or an oversight depends on how generous you're feeling, but the architectural question is the same either way. When your developer tools are closed source and cloud connected, who actually controls what they see and what they send? This is where the irony gets genuinely instructive rather than just amusing. Alibaba isn't wrong to ask the question. Any enterprise running proprietary code through a third-party tool that can read your entire code base should be asking that question. The fact that it's a Chinese company asking it about an American tool doesn't change the engineering logic. It just makes the politics louder. The real story here is that every company using AI-powered developer tools is now sitting on the same architectural decision. These tools need broad codebase access to be useful. That access is also a surface area, and when the tool is proprietary, your security posture depends entirely on trusting someone else's incentives to stay aligned with yours. That's not engineering. That's faith. The open source alternative isn't hypothetical. Local models, open weights, tools you can audit line by line. They exist. They're getting better fast. The trade-off used to be capability. That gap is closing. One commenter puts it plainly. Enterprises are becoming much more cautious about developer tools that can read large portions of proprietary code bases. That's not paranoia. That's engineering due diligence catching up to deployment speed. The question was never whether AI coding tools are powerful. The question is whether the architecture lets you verify what that power is actually doing. Open systems let you answer that. Closed ones ask you to trust. Moving on. In the argument, code is of the way, single swordly say, cow, way v, back to book discoven. And that keep us, brand, no icro, and study is that rust, traven. That of the allegation to back of a zill. The point was that the C ran everywhere, one rewrite, and suddenly an operating system wasn't welded to a single machine anymore. It could move PDP 11 to Interdata 8, that I-30 SIF to VAX, portability as liberation. 53 years later, a developer named Fractal Fur has done something that rhymes with that moment in a way worth paying attention to. They've taken the entire Rust compiler, all of Rust, and translated it into 46 million lines of C, not by hand, not with an LLM, with a tool called Silly, a Rust compiler backend that generates C code as its output. This is the 14th attempt over 3 years. 14. The technical details matter here. Silly doesn't just dump C and hope for the best. It generates what it calls witness programs. Small C snippets that probe what a specific compiler on a specific platform actually supports. Thread local storage? Float sizes? Integer formats? It asks, then adapts. The generated C targets your compiler, your architecture, your operating system. It tries to assume nothing beyond ANSI C, the 189 standard, the lingua franca of every processor that has ever had a toolchain written for it. The goal is precise and worth stating plainly. There are systems out there, real hardware running real workloads that have a C compiler but will never get an LLLM backend. Every time a critical project adopts Rust, those platforms lose access. Silly is the bridge. You write Rust. It becomes C. The ancient compiler on your ancient system handles the rest. The network transparency feature deserves its own moment. Silly can talk to remote C compilers over TCP. You run rustc on a modern Linux box, and Silly sends the generated C across the wire to a Plan 9 VM, or theoretically over UART to something with no network stack at all. This solves the bootstrap paradox for platforms that can't host a cross-compiler. What Fractal Fur has built is portability as infrastructure. C's original gift to computing was letting software move between machines. Silly uses that same gift to carry an entire modern language ecosystem to places it was never designed to reach. The tools exist. The 14 failed attempts exist. And now the working one exists too. Carrying software to places it was never designed to reach. That principle applies to people too, not just platforms. 18 hours. That's how long it took a developer to accessibility. Test a purchasing approval workflow built on Microsoft's platform stack. The original estimate was 2. The gap between those numbers is the entire story. The fundamental problem isn't technical complexity, it's architectural control. When a blind accessibility specialist sat down to test this workflow, she couldn't even use Microsoft's own browser apps with their screen reader. The platform was broken before the review began. They had to switch from Teams to Zoom. Not for preference, but because Microsoft's own video conferencing tool wasn't accessible enough to test Microsoft's own products. Sit with that irony for a moment. Then came SharePoint. The developer built a status page. Straightforward, functional. And shared it in read-only mode, which is standard practice for approval workflows. SharePoint responds by appending the words read-only to every single field on the page. If you're looking at it, you barely notice. If you're listening to it through a screen reader, every line of content comes with a 2-word tax. For Braille reader users, those extra characters physically displace the information that matters. The developer searched for a fix. There isn't one. That's how SharePoint worked. And it kept happening. Power Automate's native approvals app in Teams, invisible to screen readers. JAWS, one of the most widely used screen readers on the planet, had compatibility issues reading approval emails in Outlook. SharePoint generated multiple H1 headings per page, which for a screen reader user is like walking into a building where every door is labeled main entrance. You can't orient yourself when every landmark claims to be the most important one. The question nobody at Microsoft seems to be asking is this: if your own accessibility specialist can't navigate your own platform using your own tools, who exactly did you build this for? Every one of these failures lives at the platform level. The developer couldn't fix them. No developer can. When you build on a closed platform, you inherit its assumptions about who counts as a user. You can file tickets, you can write workarounds, but you cannot change the architecture. That power belongs to someone who has apparently never listened to their own product being read aloud. The tools to build accessible software exist. The knowledge is well documented. What's missing is incentive inside organizations that already have your money. 9 stories in, and we're not done yet. Let's talk about something the Linux kernel team quietly got very right. I'll work with what I have from the title and comments to write this segment. The story is about a regression in Linux 6.9 where crypt setup lux suspend, which is supposed to wipe disk encryption master keys from memory during suspend. Stopped actually doing so, leaving keys exposed in RAM. Here's the script. What does it actually mean to trust your operating system? Not trust it the way you trust a brand. Trust it the way you trust a lock. Mechanically, verifiably, by watching the bolt slide into place. For years, Linux users who cared about disk encryption had a specific answer to this question. You run crypt setup lux suspend before your machine sleeps, and the kernel wipes your lux master key from memory. The bolt slides. Your laptop could be stolen, the RAM frozen and dumped, and the attacker would find nothing. The key was gone, except since Linux 6.9. It wasn't. Somewhere in the kernel's DM crypt refactoring. The kind of routine code reorganization that happens constantly in a project this massive. The actual key wipe stopped happening during lux suspend. The mechanism still existed. The command still ran. The system reported success. But the master key sat in kernel memory, uncleared through every suspend cycle, for over 2 years. Let's follow this to its logical end. You're a journalist, a dissident, a lawyer with privileged client data. You've configured your system correctly. You've read the documentation. You run the suspend command every time you close your laptop lid. And for 2 years, you've been carrying your encryption keys in clear text RAM, believing they were destroyed. Your threat model was invalidated by a mischeck in a C refactor, and nothing in the system told you. Now, some of the commentary around this leans conspiratorial. Was this intentional, a backdoor? The more interesting observation comes from the people pointing out how routine this kind of failure is. A single missed line in a refactor. It's the kind of bug that open source is uniquely positioned to catch, because eventually someone reads the actual code path instead of trusting the abstraction. That's exactly what happened here. This is what verification looks like in practice. Not a brand promise, not a certification. Someone tracing execution through source code and discovering that the bolt wasn't actually sliding. The code is open. The bug was found. The fix can be audited. The alternative: we can't read the source, means you never find out at all. And reading source code is just the beginning. Pause. Let's talk about what happens when you give developers real tools to work with their browser. Let's be fair to Apple here. They adopted MCP, an open protocol created by Anthropic, instead of building something proprietary. They're giving agents direct access to Safari's DOM. Console network requests screenshots. That's genuinely useful. If you build for the web, you need to test in Safari, and this makes that testing dramatically better. Credit where it's due. Now let's talk about first principles. What does a web developer actually need? They need to know how their code renders across every browser their users touch. That's the requirement. Strip away the workflow marketing, and that's what remains. A developer in Berlin, a freelancer in Lagos, a startup in Jakarta. They all need to verify their sites work in Safari because hundreds of millions of people use it. Here's a constraint Apple won't name. You cannot run Safari without Apple hardware. There is no Safari for Linux, no virtual machine Apple willingly provides. One of the commenters asked this directly. How do you test on Safari without Apple devices? And the silence is the answer. Apple ships a tool that makes Safari debugging faster. But only if you've already paid the entry fee for their ecosystem. MCP is an open protocol. Safari is not an open browser. The server sits at the intersection, and which fact matters more depends entirely on whether you already own a Mac. The developers who most need cross-browser testing. Independent builders, small teams, people shipping from hardware they can actually afford, are exactly the ones this doesn't reach. A faster debugging loop inside a walled garden is still a walled garden. The protocol is open. The platform is not. Architecture tells you everything. This has been your daily tech feed for Hacker News for July 3rd, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build something worth trusting. We'll see you back here tomorrow.